Welcome, everyone. Thank you for joining us tonight for this evening's MOOC. Tonight's MOOC is an introduction to machine learning with Barclays. So, backstage, you have me, Aileen. I am a Code First Girls brand ambassador. So, if you have any questions about Code First Girls or other classes and events, please put them in the chat and then I'll get back to you. So I'm currently a delivery manager in fintech. I used to work as a chemical engineer in the energy industry, but managed to switch over during COVID, which is pretty cool. So I'm really excited to have Smriti from Barclays with us tonight and delivering the session. We'll have Q&A at the end, so do send your questions in by typing them in the comments. So I'm just going to add Smriti onto the stream. Hi Smriti, good to see you.
Hello, hi Ellen. How are
So
you?
Smriti, I'm very good, thank you. I'm really excited for what you're going to share with us today. So Smriti has 8 years of experience in IT. She joined as a Java developer before switching to automation. She loves to explore and learn new technologies. She has done courses on Hadoop, data science, and big data, which makes her comfortable in the world of data science and automation. Quite a lot there. She currently works at Barclays as an automation developer. Outside of work, Smriti is a traveler and a foodie, loving to explore new places and cultures. So yeah, welcome. It's really good to have you here. And I'm gonna hand it over to you so you can deliver your content. But thanks for joining us, Smriti, and thanks for everyone for tuning in.
Thank you. Thank you for giving such a good platform to share.
No
Okay.
problem. All right, when you're ready, you can share your screen, and then we can kick off.
Sure, I'll start sharing my screen.
All right. Yep. All right.
Uh, Able to
Enjoy.
see my screen? Yeah, okay, thank you. So, thanks all for joining. I'll brief you about what is AI and what is machine learning from my point, okay? So, what is machine learning? Like, why it is a hype and why do we use machine learning and why we see like in day to day people are moving towards AI and machine learning. So, machine learning is just the study of computer science algorithm which uses data automatically, like it learns on its own. So, for example, take a standard algorithm. So, if we have to analyze any data, we need to write some code, like if and else statements, some switches, something to analyze it. But in machine learning, we just have to give the objective, give the data, and it does it work. So it is super engineered. Okay. Now, a very good example, like my favorite examples for machine learning, where it is used behind the scenes and we do not know about it, are these four. The very first is Netflix recommendation engine. So, for example, I love horror movies. Okay. I have seen Grudge, Ring. Okay. And in the world, somewhere some ex person or like some set of person who also like horror movies as a genre, and they have liked other movies in horror, and I haven't seen that. So what will happen soon as they see that, okay, I haven't seen any some of the horror movies, it will populate in my list. So this is how the recommendation engine works. Behind that, machine learning is working. It verifies my genre with the words and it checks whatever I have seen, whatever I haven't seen, and it adds up to my playlist. Now the second is handwritten digit recognition. So like in the postal code or somewhere it is used. So as we can see on the screen, there are three ones over here. Okay, as a human we can understand there are one like there are three ones on the screen, but now if you have to code it to understand, there will be a lot of if and else case. For example, if I have to code it, I'll go with the pixel, with the intensity, how it is aligned horizontally and vertically, and it will work on this data set. And suppose someone writes another one which is in different format, my code will break. But how machine learning works over here, it it trains on this data set, it understand how one is generated, and as soon as you put another data set over there, it will automatically identify like how human works, similarly how machine learning works. I'll explain this example in more detail in my next slide. Okay, the third one is Google Translator. As you can see, like in English, I have written my name is Smriti. It translates in Hindi. So behind the scene, it is machine learning. The important one nowadays, which we are using, is face detection. Like in bank, or if you go for immigration in your mobile, we do face detection. Even a small app like an Instagram, we have to do a beautify, or we have to use like false eyelashes or some makeup. Over there, we do a face detection. Behind the scene, there are code which is working on it, and it is like machine learning algorithm which will identify the pixel of your eyes, and it says yes, this is the eye, this is the nose, and then it applies the filter. There are some more examples of machine learning. So see, it's not limited to some problem. Like in my day to day life, I can correlate many things which is now driven from normal coding to the machine learning. For example, object identification, recognition, and segmentation. Machine translation, like from English to French or from any language to any other language. Bank transaction categorization. For this, I can explain you in more detail because I'm from Barclays. So if you do a grocery shopping in in Tesco, so it give you a categorization that you have done a grocery shopping. Okay, at the end of the month, what will happen? It will tell you that you have spent so and so much pounds on your groceries. Similarly, it will tell you for detail, like if you are going to Asda for fuel, so it will tell you you have spent this much on the fuel in this month, you have spent this much on the utility. So this is how the transaction of the categorization works in the bank. Chatbot. Chatbot is a very good tool, I'll say. Like suppose in the very odd hour, you have to deal with some of the customer care service and they are not there. So chatbot will pop up and it will ask you the question, and probably it will navigate you to the useful link, so that even if the customer care service is not there, it is helpful for you to get to that link and get the answer. Speech and other are like speech recognition, medical diagnosis, power demand prediction, anomaly detection, driving car. So you know Tesla, and there are like other elec driving companies which are now automated with the help of machine learning and AI. Spam detection. We have in Gmail where we have a spam folder. Even I have also worked on spam detection. It's a very small project which I have worked on. Probably in the demo, I'll show you like how we detect it as a spam, like a text which I have caught is a spam or it is a good message. Then sentiment analysis. So on the basis of whatever I say on the Twitter or on the Facebook, we can say that whether it is a negative sentiment or positive sentiment. So these are like on the high level where we can see like machine learning are involved. Okay, so as from my previous slide, I showed you like how we know on the screen it is 3. Now, if I go to my code and say that, let's say that it is 3 from my code, from my standard algorithm, I'll go with the pixel and its intensity, how it is aligned. Okay, so I'll write a lot of if and else case to suggest that the very first picture is 3. As soon as it deviates from top to down, like in my next picture, you can see my 3 is just moving up and down. Okay, on that basis, my code will fail. Okay, but what machine learning does is I need to provide a correct label to this. Okay, so my label for this is as 3, and I'll provide a different kind of data set. So suppose I write 3 like this, you write 3 in some other way. Okay, but I'll label it as 3. I'll ask my model, I'll tell my model to get trained with the data set. So it will recognize how it is working, what is the curve, what is the intensity, how someone is writing 3. So that in unseen data set, if someone has provided 3, it can easily understand that this is 3. So how a human works, just seeing the pattern, that's how machine learning works. We don't have to write any condition or any if and else condition to it. Okay, so for the same problem, what we need to do is we need to gather a lot of images with a handwritten digit. For example, I'll ask my friends, if I'm working on this project as a personal project, I'll ask my friends to write three and give it to me. So they will send it out, the image to me. I will correctly label it them as three. Okay. So for example, someone has written one, two, three till zero. Okay. Like zero to nine, then I'll label it correctly, like 1 for 1, 2 for 2, and so on. Labeling is very important. If I don't label it correctly, for example, I'm labeling 1 as 2, 2 as 3, my machine learning, how I am identifying to him, it will understand like that. So, what will happen in when I'm going to test it out, my 2, instead of saying it is 2, it will tell it is 3, because I have labeled my data set incorrectly. So it is very important to provide a correct label. Then we need to define an objective function. Okay, I'll explain what is objective function, why we need it. Actually, the objective function is to fetch the data, clean it, and use it for the machine learning algorithm. Over here, to use, like, to identify the image, I'll use CNN. So CNN is convolution neural network, which we use. It will start processing it. It will train itself, like my 1 is labeled to 1, 2 is labeled to 2. Okay, that is my, I'm training my model on a training set. Then I'll test it out. How I'll validate it, like what is the percentage on my data set. If I'm providing 1, is it identifying 1 as 1 or not? Okay, so like that. Then if it is making any mistake, I'll penalize it. For example, just an example, okay? So to a dog, if we want to train him, so what we do, if it is making any foul, I'll just scold him. And if it is making a good thing, I'll just reward him. So that's how we also train our machine learning. So in my CNN, if what it has to do is to put a to get a best solution of that problem. So if it is getting a best solution of that problem, I'll reward him. Okay, and if it is taking a longer way, then I'll penalize him. It will be like it will he will be punished until and unless it gets the best solution out of it. Okay, and this is how a baby learns. So that's how our machine learning model also learns. Okay, so machine learning we have categorized into three kinds, like one is supervised, second is unsupervised, third is reinforcement learning. In a very layman language, so supervised learning is how teacher teaches, like we have a feature, we have a target, we know what should be the end goal, we'll have a labeled data. So in a supervised learning, the very important piece is a labeled data. If we have a labeled data, we can train our model. Unsupervised, so it is like a very different scenario, where we have only features but we do not have any target. So we don't know what is our target, and we ask our model to learn. So that is our unsupervised learning. And the difference between supervised and unsupervised is, in unsupervised we use unlabeled data. So we don't have to label the data on our own. We just feed our data to the machine learning, and it automatically checks the two data point and create the relationship between them. Reinforcement learning, like what I have told earlier, it's kind of an agent which we put in an environment, ask them to learn on its own on the basis of punishment and reward which we give. Okay, so if we punish them, they know this is wrong, this is not correct. And if we reward them, they think yes, this is the best way. Okay, so these are the different kind of machine learning algorithm which we use. So in detail, in today's session, we'll go through the supervised learning in detail. So as I told about the supervised learning, let's get into like what is supervised learning to more detail. So in supervised learning, it is the most basic of machine learning, where we use the label data. even though the data needs to be labeled accurately for this method to work. It is extremely powerful in under the right circumstances, and if we provide a correct label data to it. Okay. In supervised learning, what our machine learning algorithm does is like we just feed a small training set. So in unsupervised, we have to give a larger training set to understand how it works, but in supervised, we have to give only small training set to it. Okay. The bigger data set, we preserve it for our testing purpose. So this is the supervised learning. This is the main points. It identifies like what are the characteristics and it learns. And if we provide our data set for the validation, it correctly labels it. It tries to minimize the gap between the actual and the predicted. So the variance between them, it actually tries to minimize it. In unsupervised machine learning, the advantage of this is we have to provide an unlabeled data. We don't have to bother about like labeling the data in the correct way. So the human label is not required over here. We just have to provide the data set in a machine readable and allow them a much larger time to train, because they need to create two data, like they need to create a relationship between the data points. So that's the reason they need some more time to analyze and to get trained. So the relationship between the data points are built by the algorithm, not by the human. So there is no human input required over here. Only we need to provide is the data set. Reinforcement learning. So this is my favorite, but I'm still learning in this. So reinforcement learning is it's the feature of algorithm that improves on its own, because it's like how you teach them on the basis of favor and non-favorable condition. They try to adapt that so that we try to give them more and more rewards instead of punishment. That's how reinforcement learning works. Okay. Based on the psychological concept of conditioning, reinforcement learning works by putting the algorithm in a work environment with interpreter and a reward system. That's the main goal of reinforcement learning, is to get the best possible solution for the best possible reward. Now, okay, so supervised learning. So we categorize like our machine learning algorithms are of three types: supervised, unsupervised, and reinforcement learning. Even under the supervised machine learning algorithm, there are certain other algorithms. So few of them I'll walk you through. So linear regression. I'll also go to other algorithms and I'll tell you the difference between linear regression and other machine learning algorithms, and how we can choose the best machine like best of out of these in our problem. We can see in the demo. So, linear regression. This algorithm fits in a line. So, it is very simple from the name itself. It is a linear, but sometimes it is actually not linear. What it does is over here in that example, we can see how the house are varying, like from small to large. That's how the price is also varying. Like the small house, it is costing around 70 grants. Then if we move to a bigger house, it is between 10 to 15. And now if I am purchasing any bungalow, it is around 160 or something. Okay. So if any house which is in between the small, medium, and large, suppose it fits between these two, it will give you the range. This is how the linear regression works. The model is defined on y equal to mx plus c. Okay. This is the mathematics between with this. So the model tries to learn the value of m and c given the data set of y and x. Y and x are in capital, which is in our um, in the graph itself. Okay, what it does is it does it tries to minimize the error between the capital Y, which is the real value, and the small y, which is the predicted value. So the difference between the two, if it is minimum, that means it is accurate, and that's how it calculates the accuracy. Okay, so suppose in future, if one of my friend, he's buying a super bungalow, which is Excel. Okay, so from here we can predict the value will be around from 16 to 20. So it will just fit it over here and say that the price will be 20 around. Okay, this is how the linear regression work. Now the second one is logistic regression. So it is very simple. This is actually based on binary classification algorithm, which is 0 or 1. For example, 0 is true, 1 is, 0 is false, true is 1. So it works like whether it is pass or fail, cat or no cat, dog or no dog. So how you label your data set? hmm? For example, you are labeling it as apple, but labeling it as red, and the second one is as green. It tries to draw a line between two, put it in a different class, and just check like that. So if it is red, it will place it below the line. If it is green, it will place above the line. That's how our logistic regression works. So in both scenario, we can see how our data set is very important over here. The labeling is very important. If I'm not labeling it correctly, it will not put that data in the correct class itself, because over here we can see above the line it is green. So if I, in my data set, I'm saying that in, like, the color is red, but I'm saying that it is green, it will not put it in the above the line, it will put it below the line. Okay. Now the third is random forest. So random forest is basically, this method is based on the collection of decision tree. Okay. So what it does is, for a given data set, it tries a lot of permutation and combination. It tries to generate decision tree on it. Okay. Multiple trees are generated, and it actually takes, suppose if I'm giving my data set, so my data set have my training data set has around 100 feature, so it takes only 90 features out of it. Okay, and it tries to generate my tree. So in my first tree it takes the top 90. In my second tree, it leaves my 10 feature, it takes another different 10 feature, like with the permutation combination, and it generates that tree. In my third tree, it takes another feature and it generates. There are some similarity between tree 1 and tree 2. So what it does is, according to the tree, it comes to the decision, say like the first tree is class A, the second tree is class B, third tree is class A again, my fourth tree is class C, my fifth is class B. So what it does in the end is, it sees what is the majority vote. My majority vote goes to class B. I can see there are n number of class B, like there are 10 class B, 8 class A, and 1 class C. So it will say that my feature is class B and the vote goes to it. And that's how it trains it. So this were the some of my machine learning algorithms which I have worked on. Now, how to set up a problem. Suppose I'm a newcomer to the machine learning and in AI world. So if I want to start working on my personal project, how should I? So first of all, I need to think about a problem. I need to gather the data. Okay. For supervised learning, I need to label the data correctly. For example, x1, x2, x3, and y. Okay, there might be some noise, that's fine, like it's okay to have some noise. So we can see, like in our function, how we define a function is f of x equal to y plus d is some random noise. Okay, so we take a unprocessed, like unknown processor of f. Okay, we generate the data as x and y. We observe the data of like small x and y which has some noise. Okay, and we input it to our machine learning model. What my machine learning model does is it infer what you are giving, whether it's an apple, whether it's an orange. Suppose I'm just taking a normal classification model where I just want to tell, like, if I have a red color, uh, round shape having a depression on the top, it's an apple. If I have a fruit of orange color, it's also a circle, so it's a orange. So based on the color and depression, it will identify and it will say on my unseen data, like, yes, if I am providing something of red color and with a depression and kind of that of image to say, yeah, this is apple, this is orange. But if I say something like, suppose I'm giving a golden apple, it will not understand. It will try to fit it. Maybe it will give you a correct value accordingly. So what we need to say, like, we need to know what kind of apple exists in the world. We know it's red color, pink lady apple, golden apple. So if we have multiple data set for training, we provide it to the machine learning model, it will start learning it from there. And suppose in future someone provides a green apple or golden apple, hmm, it's good to go. It will tell you, yeah, this is apple, rather than it's a orange. So that's how it works. Now, issues with learning. So what are the issues what I can come up like while I'm training my model? So these are some issues which I came up and I thought, like, while learning my machine learning, am I doing it correctly? Like, how we are making sure that we are, like, our model is not like, it's generic, it's not based on what I have trained. Like, I've just given my training data set of around 100 images, so it's not like it's only identifying to that 100. It is working as good on unseen data also. How do we select different kind of model, loss function and matrix? Because if you go on searching for machine learning models, there are a lot of models available. So which model to select for my project? How do we interpret whether the model has learned, especially we are basing our high stakes on, for example, medical purpose or stocks. So in the medical field, if any prediction is wrong, the stakes are high. Same for stocks. If I am seeing like the stock value of my XYZ, it's going to be a lot, okay, and I put my money 100 grands over there, it's a lot. So the model should work and learn accordingly where the stakes are very high. So these are like my, okay, while implementing it, I go around and search like what to do. Am I doing it correctly? How do we know how much to train the model? Like, there are the concept of overfitting. So am I overfitting my model? So how do we get around that? How do we go about the collecting the data? Because for example, for Apple, it is very easy. But if we are working on a very complex data set, so how about collecting the data and then labeling it correctly? Because in supervised learning, we have to label it. If I'm not labeling it correctly, then I'm missing some of the data. Then there are some biasness in the data. For example, in a standard word, like, my model shouldn't learn like a nurse means, like, if a woman is there, then it is associated to nurse. Doctor means it's male, it can be anyone. So how should I understand like my model is not biased? So these are the different issues which I came up while learning it. Some of them I got clear while doing, and by using hit and trial method, I'll explain like what are the general solutions to it. So for journalization, so what we do, we divide our data set. Suppose you have a data set of 100, okay? You have 100 different images of an apple. So how to train your model? So take some of them for your training, some for validation, like verification, and some for the test. Tests are like unseen data, okay? So on the test, we give a prediction how our model is working. We train our model to a training data set, and also we do a hyper tuning. Hyper tuning or hyperparameter tuning is what, which model cannot learn by itself. So we need to tune that. Then Properly, we need to validate our data set, and then we need to train our model on that. This way, we'll see that our model is generic. It's not biased to only what data we have provided. Okay. And of course, we have the validation and test records. So once our model is learnt enough, I'll just use my test to test it out and predict how my model has worked. Then model selection based on particular cases. For example, CNN are like, we use it for state of art for computer visions. Transformer or RNN are for sequence modeling. Logistic regression decision tree are for classification in the tabular data. So as you grow in the machine learning, as you grow your experience, you'll get to know which model, where to utilize, where to use it. Interpretation can be very easy and can be hard, or can be like, you it's near to impossible, but it's okay. Okay. Total training time depends on like, on the training data set. So if your model is, you are using supervised, it will take lesser time. If you are using unsupervised, it will take a lot of time to get trained, because there you are not using any label. It needs to understand on its own. Okay. The data can be a bit noisy, but we need to clean our data. Some noise is fine. It tries to learn from the noise itself. Okay. And with respect to the biasness, we need to know it before. If we know it before training it, we can remove that biasness from our data set itself. Okay. Let's quickly have a look to the demo. So what I'm sharing over here are the project which I have worked on as my personal, and this is how I learned it. There are various other projects available on the Git. So but I chose to show two of them, and let's quickly have a look to it. So the very first one is, what I have done is I have collected the image from Google for sandwich and sushi, okay, to identify whether the image is sandwich or sushi. So I have used CNN over here to model it, and let's see how it works. So what I'm seeing over here is, it has worked absolutely fine. There are some flaw where it was very hard even for us to identify whether it is a sandwich, it is a sushi, whether it's not, it's none of them. Okay. So from here you can see like sandwich is 0, sushi is 1. Okay. So TR0 is 0 over here. That means it is identifying this as a sandwich, which is fine. It's still hard for us to identify whether it's a sandwich or not, but our algorithm has correctly said that it is a sandwich. Now for this is also a sandwich. This one, it is identifying as a sandwich. Now come over here. It is identifying this as a sushi. How? Because it's of a round shape, something black over here. It identifies this as a sushi. Now, if I see this picture, this, it has identified as sushi as one. Now, I'll quickly show you where it hasn't identified or wrongly classified as something else. So see, this one, it is identifying it as sandwich, but we do not know whether it's a sandwich or it's a sushi. It's something else. Same for this one. It is identifying it as a sandwich, but I can see it's like a mac and cheese. I don't know whether it's a sandwich or what. But even for a human to understand this as a sandwich or as a sushi, it's very difficult. But still, machine learning tries to say that this is a sandwich, because sometimes people makes bread pizza or something and it is trying to classify this as a sandwich over here. Okay, so let's go on the top. I directly showed the result. I'll show how it is working. Okay. So what I have done is I have classified, I have fetched the images, and I have categorized it as train for the training, val for the validation, test for the testing. Okay. There are different, like there are some noises, because noises are like the shapes are not correct, or I am giving some incorrect value, those are considered as noise. Okay, so I'm just trying to make it as clear as possible so that my training set is correct and it is homogeneous. Okay, then what I have done is I tried to train my model over here, and you can see this is all for the training. I'm using a CNN network over here, and it is trying to train. It takes some time to train over here. Okay, so my total parameter is this much. Okay, and I have trained it. Now I again tried to train it, and it took some time. Around it took me around an hour to get it trained. Okay, and with the help of my matplot, what I have done is I tried to see, like my training graph is this, my validation is this much. Okay, so this to be minimized, it's zero point 0.8 and this is around 1, as minimum as possible is the perfect solution. Then what I did is, like, I tried to test it. I am using test generator over here, where my testing my unseen, which my learning model hasn't seen my data set, I have kept it over here, and I'm trying to test it out. Just one line of a code over here to test it out. See, and I can see out of the training set, my false, which it hasn't verified correctly, is 13 plus 9. Okay, so around 22 of them were not identified correctly. Rest of them, like 101 plus 59, were identified correctly. So my accuracy, if I print my accuracy score of my model, it's 87. Okay, accuracy of the model is 87, around 88%. Okay, and this is another, like I'm just checking whether it's overfit or not. So I'm just seeing that it is 93 over here. So 89% it is accurate. So that's how my CNN worked over here. And then what I did is, like, I just tried to see it whether, like, I use my other functions to generate the uh, pictures over here, and try to verify with my own eye whether it is identifying it correctly on my test set or not. And I could see that yes, it was identifying it correctly, and there are some point which it wasn't. Even I was not sure whether this is a sandwich or what is it is. So it's fine. So this is one of the example. The second project which I have worked on is spam detection. So what I did, this was the very first project which I have worked on. So I took some of the WhatsApp messages. Okay, I labeled it correctly. So ham is something which is correct, spam is which is not correct, like which has to go to the spam folder. Okay, so this is how I labeled either ham or spam. Okay, now what I have done is I have created feature on the basis of, like, what it is used in spam and ham. So in spam, I can see there are certain spelling mistake, or like there are certain thing like call, win, mobile, free, offer. So these are something which I can see that was repetitive in spam. But in ham, there are few spelling mistake like sorry, love, go, ill, call, good, need. So these are something which is not spam, and it is some of my friend who has sent it out. So it comes to the ham. So what I have done is I have used over here is random forest and logistic regression. So this is my first project. I was not sure which model to use. So what I did, I took my random forest over here. I started to train, and then I validated it. Okay. So in my test, I can see 32 of them were incorrect. Rest of them, around 1100, is correctly like said, like whether it is a ham or spam. Then I try to move to another one, which is logistic regression. Okay, so in logistic regression, my prediction, I can say that only 22 over here, it was 32. only 22 were incorrect, rest around 1100 are correct. So I try to get the accuracy, so I can see in my random forest 97% is my accuracy, in my logistic regression it's 98% accurate. So that's how I came to know, like, okay, I'll use my logistic regression for this to get the correct picture. Now I can quickly show to the result. So this is my test set. See, sorry, I missed you something. Okay, so it's not a spam. Then finished already, yeah. So this is something which my friend has sent. So it's not a spam. Okay, something which is a spam. Okay, it's not a spam. Okay, this one is a spam. So something increments help this. So this is something for the increment, okay, and 150 pound increment help, and this is the number. So I had identified it as spam. Now I'll quickly show like what is reinforcement learning and how it looks like. This is the like something which I wanted to learn and which quickly show how it works. So this is the animation. It's in the working environment, tries to reach from point A to point B. So nothing has been specified to him, like whether it has to jump or something. It teaches itself, okay? Just it has to reach from point A to point B. And this state, it hasn't been done in like just 5 minutes or 10 minutes of learning. It takes ages to learn and ages to learn. It evolves, like you will see in this one, it will start moving his hand. So this is like reinforcement learning. See, it starts moving his hand. I believe like it tries to balance itself. That's the reason it starts moving his hand like that. So if the balance is wrong or if false, we do not reward, we punish. So see, it jumps and it fails. So it gets punishment. And that's how it learns. Okay. Yeah, cool. So that was the demo. So the brief introduction to the deep learning. So in deep learning, what we use are like, this is the advanced topic of machine learning and AI. So the different kind of neural network which we use, actually we use it for SOTO algorithm, like we use it for computer vision, like convolutional neural network, we use it for computer visions, we use it for sequencing modeling. These are like, deep learning is the advance of the machine learning. And that's it.
Great. Thanks so much, Smriti. That was really, really good. We do have a question from our audience, and it
Mhm.
is, what tools or libraries do you recommend to start experimenting with machine learning?
Okay, so for machine learning, the very simple libraries which we use it, scikit-learn. So it's very easy with Python, but if you know Python a lot, then you can go ahead with scikit-learn to use it.
Okay, that's great. Some other questions that we have is more to do with your role at the moment. So
Mhm.
it's like, what does your role involve day to day?
Okay, so in Barclays, I'm an automation developer. So whatever I see that we are doing manually, I automate it, either with the help of Java, Python, somewhere machine learning. But sometime it happens like I'm not working on my machine learning or data science. So what I do for myself is, so that I keep myself up to date with machine learning, is I try to create small project. I try to take or participate in hacker rank or hackathons.
That's really cool. So you do the hacker ranks as part of your day-to-day job as well, or is that more on the side for you to keep
No, more
learning?
of a more
Oh,
of a
that's so
side.
cool.
Yeah.
Yeah, that's really, really cool. Okay. And what about what skills do you find most useful in your role?
So the skills which I find most useful in my like day-to-day activity are like Python, because I was a Java developer initially. So I have to code a lot in Java. But when I moved and when I learned Python, I find it very simple. Just 4 lines of code and job is done. So I find, yes, as a skill, Python is a good thing.
Amazing. Right. And how did you become interested in tech? Like, what was your journey? So we know that you have around 8 years of experience, right, in IT. But when did that start?
It started when I was doing my high schools. So that moment I saw like there were few questions. So none of my parents were into IT sector. So there were few questions around science, how it is working, how the IT is working. So I did my engineering in electronics and computer. Okay. So I was more into physics. So I was a physics girl. Then in that one of the semester I learned about computers and what is the coding, how it works, and basically the Netflix engine, or like Google, even like on a Google we see that there are ads, how it is working, and on the basis of whatever I have seen on the Amazon, my Google actually sees and it tracks me like, Smriti, you need to purchase this boot. Smriti, you need to purchase this boot. So behind the scene, how a code is working, I was very interested in that.
Mhm.
So I chose to become a computer scientist over here. So I
Mhm.
went into software industry. So rather than applying to any electronics industry, I started applying to computer based industry. So my first role was in Cognizant. So they recruited me and I started as a Java developer.
Oh, very, very cool.
And then I was a Java developer. There was a like I switched my career from Java developer to big data. I did my certification in big data
Yeah.
because being a Java developer, and I was very curious about how like there are so many data, how we are modeling it, how our, and yeah, there was a big data was in hype at that moment. It was around 2013 and 14. So I thought of like, yeah, doing the certifications around big data and get to know about the data, how our market is working, what is Hadoop and all. Yeah.
Oh, very, very cool. And just looking back at that journey that you've had, what do you wish you knew at the start of your career?
Statistics, probability, and machine learning at that moment. Because in my higher studies, when I was doing statistics were the subject, and like, oh, okay, I'll learn the mean, I'll learn the deviation, and that's it. But now I know, like, okay, how probability, statistics, behind the scene, machine learning actually use statistics and maths. So you need to have the base understanding of that, then only you progress forward. So yeah,
Yeah, if you
I
could
could,
turn back time.
yes, seriously, I could have been more serious towards maths.
Ah, and would you have done anything differently?
No, I'm happy with the path which I have chosen. But yeah, if with the experience which I'm having, if I can take back, then yes, I could have trained more people, and yeah, I could have trained myself. Yes.
And the very final thing, I think, is what is the one thing that you want our audience to take away from tonight's session?
Be more curious. Always explore. Never stop learning. That's the journey. Just never stop learning. Whatever you have any query, just explore. and you will get the answer. There are so many blogs. Go to Coursera, go to Udemy. You'll find a lot of things around what is evolving. Computer vision, quantum computing, machine learning. These are just a start. So start
Mhm.
learning from, like, take some baby steps and you are there. Start with smaller project like how I showed with sushi and sandwich. Initially, it took me a lot of time to train my model, to clean my data, but ultimately once I got the accuracy of 98%, I'm like voila.
Yeah, that's a really, really good tip to just keep on asking questions and keep on
Yes.
exploring. I think that's a really, really
Yeah.
good thing to do. Um, okay, great. I don't think we have any more questions from the audience. But
Mhm.
yeah, thank you, Smriti, so much for your time and taking us through your content as well as sharing with us your journey so far. But yeah, thanks again for that. I think that was really good, and I think people really enjoyed that. So I'm going to end the broadcast. I hope everyone has a good evening.
Thank you.
The video here will be on YouTube for the next 2 weeks. So if people want to come back and review the content, they're more than happy to do that. But yeah, apart from that, thank you very much, Smriti. I'm sure
Thank you,
I'll work
Ellie.
with you
Thank you,
soon.
MOP. That was a pleasure.
Excellent.
Okay.
All right. Have a good evening, everyone. Bye bye.
Bye.